So in this video, we will discuss integration by parts. Integration by parts is the first of many slightly more advanced integration techniques. Up till now in Calculus 1, you probably just learned the technique of U substitution. So this is sort of the next level up from that. And it's based on a simple observation. If we have the derivative with respect to x of a product of functions u and v, then the product rule says that we have du dx times v plus u times dv dx. So if we integrate this, right, then this gives us a rule between the integral, well, let's just do this, let's go ahead and do it. So the integral of d dx of u times v with respect to x would be equal to the integral of du dx times v dx plus, well, integral of u times dv dx dx, right? Now this, we know that the integral of a derivative is just the function again, right? Well, plus a constant, but we'll let that be counted for over there. And on the other hand, we have these guys. Now, I'm going to rewrite it this way. v du dx dx plus the integral of u dv dx dx. All right. So if we think about making a, let's say, u or a v substitution, then we can simplify this further. We can say, oh, well, that's really just the integral of v du plus the integral of u dv. And this leads us to the integration by parts formula, namely that the integral of u dv is equal to uv minus the integral of v du. This is known as integration by parts, to trade the integral on the left-hand side for the integral on the right-hand side as is boxed here. Now, we could go through the same derivation, adding bounds, right? If, say, we're looking, instead of looking at an indefinite integral, if we were looking at a definite integral, one with bounds, then it's a simple matter to follow through the same derivation, and I'll just add the bounds here. So suppose we integrated from a to b, right? If we integrated from, say, a to b, then instead of having just uv, we have uv evaluated from a to b, right? And here you got to be careful, right? If we do a u substitution, then this would be from u of a to u of b, and this would be from v of a to v of b, right? And so we could write that down here. So this would be from v of a to v of b. This would be evaluated from, well, a to b, and this would be from u of a to u of b. Now you could also have the integration by parts formula slightly more kind of clunky form. I'll write it out. So in terms of just x integrals, we'd have the following. We'd have the integral from a to b of u times dv dx dx is equal to u v, viewed as functions of x, of course, evaluated from a to b, minus the integral from a to b of v du dx dx. So in some sense, the boxed purple formula is a shorthand for the more complicated looking black one, but I think it's best at this point to go and show you some examples about that, and that's what we'll do in the next video. Thanks, guys.